Now for a few more details on magnetic induction. Remember that this coil induces a current in this coil. There's no physical connection. Let's go take a look at how that works. So let's say we have a coil with a battery wrapped around a cylinder with a second set of coils going through a light bulb. Right now we have no magnetic field being generated by this circuit, but as soon as I close the switch, current begins to flow. You can trace it through, and this current will produce a north pole on this side as determined by the right-hand rule. Put your thumb in the direction of the current, your fingers will curl through the center of the coil. Now, it's not that there's a north pole here that makes this get an induced current. It's the fact that there was none before, and now there is, so that means the magnet got stronger. We can imagine a magnet near a cylinder with a loop on it. If this magnet moves closer to this loop, the loop will have an induced current to oppose the approaching north pole, making a south pole on this side with field lines emerging on the left. Follow the right-hand rule to make this happen, and you're going to see current induced in this direction. As viewed from the left, that's counterclockwise. Well, the same thing's going to happen up here. The strengthening north pole will induce a north pole in these coils. The current induced will also be counterclockwise and will travel from left to right through the bulb. Now, what happens if this magnet stops moving? They'll have a north pole with a magnetic field extending through this loop, but there won't be any change. So without this motion, there won't be any current induced. There won't be any magnetic field induced. And the same will happen in our coil with the light bulb. Current is at its maximum value. The north pole now remains constant, so there's no more changing magnetic field, and these coils no longer have any current induced in them, and the light bulb would go out. Well, what's going to happen when we open the switch? The current stops. The north pole diminishes to 0. That would be like taking this magnet and moving it away from this loop. There would be a change. How would this coil respond to that change? A south pole would have to appear to oppose the north pole moving away. North pole on that side, field lines in that direction, and the current would be induced clockwise. The same thing's going to happen here. When we open the switch, that north pole diminishes. The north pole diminishes, and this coil will respond